Hey class, for this video today we are going to be taking a look at section 9.1 on parallelograms. Now before we get into the lesson, I just want to make note that this section is the start of your final unit for geometry. So congratulations on making it to the last unit of the course. Throughout this unit, over the next couple weeks, we're going to be taking a look specifically at quadrilaterals. So a quadrilateral is just a four-sided shape. So our previous unit, we talked about triangles. This unit, we're going to talk about different types of quadrilaterals, different properties of quadrilaterals, and all the whatnot. So, like I said, today we're taking a look at section 9.1. That's going to be our focus. And for today, our learning goal is that you will be able to use properties of parallelograms to find various measurements. So we're going to go through and talk about what a parallelogram is. We're going to look at four different properties. And then, like usual, as we have done throughout the course most of the time, we're going to go through and apply those properties in a basic format, and then also to go through and figure out the value of a variable like x or y. So let's go ahead and get into it and talk about what a parallelogram is. Before I do that, just as like I've already said, a quadrilateral is a shape with four sides. And I mention this again because I want to highlight this second part here, that all the angles inside every quadrilateral are going to add up to 360 degrees. So triangles, all the angles add up to be 180 degrees. Quadrilaterals, four-sided shapes, all the angles inside of it are going to add up to be 360. I mention that because it's going to be helpful with some of our theorems and problems today to know that all the angles are always going to add up to be 360. That's something you will need to know really throughout the next week or two when we talk about quadrilaterals. All right, for today, we are specifically looking at parallelograms. So a parallelogram is a quadrilateral, a four-sided shape that has two pairs of parallel sides. So if we look over here to the right, this would be an example of a parallelogram. JKLM is a parallelogram because it's a four-sided shape and it has two sets of parallel sides. The top, JK, is parallel to the bottom, ML. And then the left, JM, is parallel to the right of KL. So a parallelogram is just a four-sided shape with two sets of parallel sides. The sides opposite of each other are going to be parallel, top to bottom, left to right. All right, so now what I want to do is talk about four different theorems of parallelograms. So we'll go ahead and slide this up. Our first theorem that we're going to talk about today is if a quadrilateral is a parallelogram, then its opposite sides are congruent. So opposite sides are parallel, opposite sides are also congruent. So that means that the top is the same measure as the bottom, and the left is the same measure as the right. So opposite sides are congruent. They have the same measure. So that is our first property today. That's going to operate very similar to rectangles where you know opposite sides are equal. Our second property for today is if a quadrilateral is a parallelogram, then its opposite angles are also congruent. So parallelograms, opposite sides are parallel and they are also congruent. Then the opposite angles are also congruent to each other as well. So what that means is angle J is going to be congruent to angle L. So they're both going to have the same measure. So angle J and angle L are equal to each other. And then the other set is going to be angles K and M. So opposite sides are congruent, opposite angles are congruent. That's going to be our first two properties for today. All right, our third property is going to build off of the previous one. and it uses what I talked about, the fact that all the angles add up to be 360 to help bring this third one together. So this third one is, if a quadrilateral is a parallelogram, then its consecutive angles are going to add up to be 180 degrees. Consecutive angles are known as angles next to each other. So angles J and M, angles J and K, angles K and L, angles L and M. If they're next to each other in the parallelogram, they're consecutive. And as I said, they add up to be 180 degrees. So for example, let's give you a numeric representation of this. If I know angle M is 100 degrees, based off the previous property, I also know that angle K is 100 degrees because opposite angles are congruent. So using this, and this comes about using the fact that all the angles add up to be 360 degrees, angle J is going to be 80 degrees, and angle L is also going to be 80 degrees. Thus showing that consecutive angles, angles next to each other, are going to add up to be 180 degrees. So J and M added together is 180, M and L 180, K and L 180, J and K 180. So opposite angles are equal, consecutive angles are going to add up to be 180. Then our fourth theorem for today is going to be, if a quadrilateral is a parallelogram, then its diagonals bisect each other. Note, I did not say the diagonals are equal to each other or have the same measure. Yet, I said the diagonals bisect each other. Remember, bisect means that it cuts them in half. So, JL is going to be cut in half by MK, and MK is going to be cut in half by JL. So if I was marking this, I would go JN is the same measure as NL, and MN is the same measure as NK. So the diagonals bisect each other. They are not necessarily congruent to each other. They just bisect each other. So those smaller parts are key. All right, so that's the four different properties. Opposite sides are equal, opposite angles are equal, consecutive angles are going to add up to be 180, and then the diagonals are going to bisect each other. So for today, we really just have two different types of examples. Example one is going to just take a look at basic numeric application of this, and then example two, we're just going to add in the algebra component. So let's go ahead and take a look at example one first. So example one, we are provided with a parallelogram, and our directions are find the following measures from each parallelogram. So we have our parallelogram here, PQRS, and we're going to go through and find these different measures based off what we're told. So I'm going to go through and fill in the diagram based off the properties that we just talked about. Then I will go through and fill these in second. So first, let's go ahead and start with the side lengths. First property was opposite sides are equal. They're congruent. So if the right is 6 centimeters, that means that the left is also 6 centimeters. If the bottom is 10 centimeters, the side opposite the top is going to be 10 centimeters. So fairly straightforward on the side lengths. Opposite sides are equal. They have the same measure. So that's going to be the first thing we're going to take a look at. The second component is going to be the angle measures. So remember, I said opposite angles are congruent. So if angle R is 130 degrees, that means that angle P is also going to be 130 degrees. Next, I have angles Q and S. Based off that property, I know that Q, because it is opposite of S, are going to have the same measure. So all I need to do is figure out one of them, and then I know the second. And if you recall, The third property that I talked about today is that consecutive angles are going to add up to be 180. So to figure out Q, I'm going to do 180 minus 130 to tell me what Q is going to be. So if we go through and just calculate that real quick, so I'll do 180 minus 130, and we're going to get 50. So that tells us that angle Q is going to be 50 degrees. And then as I've already mentioned, that means that we also know that S is going to be 50 degrees. So now that I've gone through and filled in all the parts, I can go through and answer each of these parts as well. So we found Q to be 50 degrees, P to be 130, S to be 50, and then QP was 10 centimeters, and QR was 6. So that is how you go through and use the properties of parallelograms to find different measures based off what you were told. All right, let's also take a look at B, as B is going to involve some diagonals, so it's helpful to just see those come into play as well. All right, so for B, we're not told any angle measures, so we're not going to worry about angles in this one. All we're going to worry about is the side lengths and then this following segments inside based off the diagonals. So again, let's go through our different properties. Opposite sides are congruent. So if the top is 12 meters, that means that the bottom is going to be 12 meters because it's opposite. If the left is 13, that means the right is going to be 13. Now, with the diagonals, okay, the key thing for the diagonals is remember that they bisect each other. So they're going to cut each other in half. That means that this part is going to be the same measure as that part. And then this part is going to be the same measure as that part. So marking it helps to kind of know how it's going to translate over. So if VO is going to be 8 meters, that means that OT is also going to be 8 meters. And then if OU is 9 meters, that means that OS is 9 meters as well. Now that I have all the parts filled in based off what I've been told, I'm just going to go through and answer these parts. So ST we found to be 12 meters. TU we got to be 13. SU is going to be the entire thing here. So that's going to be this plus this. So that's going to be 9 plus 9. So that's going to be 18. We found OS to be 9, and we found OT to be 8. And then lastly, VT is going to be this entire diagonal. So that's this plus this. So 8 plus 8 is going to give us 16. All right, so that is example 1. That is going through and just applying our 4 different properties for parallelograms in a basic numeric sense. So now what we're going to do is go ahead and take a look at example 2, where there is some algebra tied into these properties and theorems as well. So let's go ahead and go to example 2 next. So with example 2, its directions are use the properties of parallelograms to figure out the value of the variables and the given measures indicated. So for example 2a, we are provided with a parallelogram here, ABCD. Knowing it's a parallelogram, I know multiple things. Opposite sides are equal, opposite angles are equal, consecutive angles add up to be 180, and the diagonals are going to bisect each other. Let's go ahead and start with trying to figure out the value of x. That's our first thing that we want to go through and figure out the value of. So the two things that I see with x in this problem are 5x plus 19 and 7x. So these two are talking about side lengths. And the only thing we know about side lengths with parallelograms is that opposite sides are congruent, which means that they have the same measure, which tells us that opposite sides are equal. So because these are opposite of each other, I'm going to take the 5x plus 19 and I'm going to set it equal to the 7x. So the key is the setup. Once you have it set up, it's just about using your algebra skills to go through and solve from that point. So I'm going to subtract the 5x to the right. And then I get 19 equals 2x. And from here, I'm going to go through to solve for x. I'm going to divide by 2 to both sides. If we do 19 divided by 2, we're going to get 9.5. And then on the right, we're going to be left with x. So that tells us that 9.5 equals x. So that means I know that x equals 9.5 in that box. So now that I know what x equals, I can use that to help me figure out what BC's measure is going to be. So BC is this 5x plus 19. If I want to know the measure of BC, I just figured out that x is 9.5. So I'm going to use that 9.5 and I'm going to plug that in for x. So we're going to take our calculator. We're going to do 5 times 9.5 plus 19. And I get 66.5 for the measure of BC. All right, so that's how we go through and figure out the value of x and then the measure of BC. Next, we're going to talk about how you go through and solve for the value of y. So there's two things that involve y. This 6y plus 5 is talking about angle B, and then the 8y minus 17 is talking about angle D. So I know two things with angles. I know that opposite angles are congruent, and that consecutive angles are going to add up to be 180 degrees. B and D are opposite of each other. So because they're opposite, that tells me that opposite angles are congruent. So that tells me that these two have the same measure, which tells me that they're equal. So I can set both of these equal to each other. So I'm going to slide over. And what I talked about was the fact that 6y plus 5 is equal to 8y minus 17. Now that I have it set up, we're going to go through and solve. So I have variables on both sides. I'm going to subtract the 6y to the right. After that, I get 5 equals 2y plus 17. Next step is I'm going to add the 17 to the left. So if I add 5 plus 17, that's going to give me 22 equals 2y. And then like usual, our final step is going to be division. So I'm going to divide the 2 off of the y. So 22 divided by 2 is going to give me 11. So in this case, I get y to equal 11. And then I can use that value of y to help me figure out the measure of angle D. So angle D was the 8y minus 17. So I'm going to use that 8y minus 17. So I'm going to use this expression here. And we just figured out y to be 11. So I'm going to plug 11 in for that y. So 8y minus 17. And we have 11 as our value of y. And after calculating that, we get 71 as the measure of angle D. So 71 degrees is the measure of angle D, which also is the measure of angle B. So that's how we're going to go through and process and set up these problems today. Opposite sides are equal, opposite angles are equal, consecutive angles are going to add up to be 180, and the diagonals bisect each other. Now, for the other two parts of this example, I'm just going to show you how you would set them up. I will leave the solving to you guys. You can always check the Google Classroom page for the completed notes if you would like to see how I finished solving parts B and C. But again, I'm going to show you the setup, and then I will leave the algebra part to you. Let's go ahead and take a look at B. So for B, again, I am provided with a parallelogram, and in this case, I have two variables. I have x's and I have z's. So let's start with the x's. The x's are pointing to the diagonal parts here. And the thing I know about diagonals is that diagonals bisect each other. So based off that, I know that this part is going to be the same measure as that part. So PT is going to be equal to TR. Because it's been bisected, it's been cut in half into two equal parts. So this setup would be x plus 9 equals 4x minus 6. So that's how you would set it up to solve for x. You can then go through and solve for that one to see what x is going to equal. If we talk about going through and solving for z, so there's two things that involve z here. That's the 2z plus 4 and the 3z minus 4. And that's dealing with side lengths. And the thing I know about side lengths is opposite sides are equal. So because these are opposite of each other, that means that they are equal. So I would set it up as 2z plus 4 equals 3z minus 4. And again, you can go through and finish solving on that. If you want a quick check, if you've already gone through and solved for x, I get x to be 3. And if you're wanting a quick check on z, I find z to be 8. So that's how you would approach B. Diagonals bisect each other, so those individual parts are going to be equal to each other of PT and TR. And then opposite sides are equal, so that's how I can set the 2z plus 4 equals the 3z minus 4. Now, if you were trying to figure out PR and QR for the different individual parts, you would plug those back into the respective expression for x and z to then go through and figure out those measures. All right, lastly, let's take a look at C. So again, we have our parallelogram, PQRS. So I've got x and n as my variables here. Let's quickly talk about x. It's dealing with our side lengths of the 2x at PQ and the x plus 3 at SR. We've already done side lengths a couple times. You should be comfortable with the fact that opposite sides are equal. So I have 2x equals x plus 3. So a fairly straightforward solving on that one would get us x to be 3. Now, if we talk about n, so n is talking about the 10n and the 8n. So the 10n is on angle S, and the 8n is on angle R. Okay, so I know two things about angles. Opposite angles are equal. Consecutive angles add up to be 180 degrees. These are not opposite of each other, so they are not equal to each other. Because they are next to each other, they are consecutive. And the thing we know about consecutive is that they add up to be 180 degrees. So I have 10n plus 8n equals 180. We're going to go through. Remember, it is imperative to combine like terms first. So I'm going to get 18n equals 180. I'm going to go through and divide, and I will get n to equal 10. So that is how you're going to go through and figure out the value of a variable when you have consecutive angles. So we've gone through and done one with opposite sides, opposite angles, diagonals, and now with consecutive angles. So you've seen every type possible in terms of how you need to go through and set it up. So that concludes our lesson on parallelograms. As always, if there's a part you missed, you can always go and look at my completed notes to kind of fill in what you need. If there's a part that you need to see again, feel free to go back and watch this again. It'll be available on Google Classroom and YouTube. Let me know if you have any questions. Feel free to email me or just let me know the next time you see me. I hope this was helpful. I hope you guys have a great rest of your day, and thank you very much.